Welcome to another day on the Journey Chez Chem. I'm so excited today because we are doing a lab. I get just so excited. So please do those warm-up questions as quickly as possible so that we can move on into the lab. The question in number 1 is very similar to what we will be doing in the lab. We are taking a variety of different salts and we are adding water. Now, the reason that I write water as HOH is because that reminds me that it separates as hydrogen ions and hydroxide ions. It is the hydroxide ions that combine with the metal to form the base. And the hydrogen ions will form with the negative position in the salt to form the acid. In this case, I get sodium hydroxide and sulfurous acid. Then I look at the strength of those, and group 1A and 2A with hydroxide are strong bases except for beryllium. Group 1A, I mean the alkali metals. Group 2A is the alkaline earth metals. So this makes this a strong base. H2SO3 is not one of my 7 strong acids, and it's very important that I learn those 7 strong acids because they will come back again and again. This one is a weak acid. If one is weak and one is strong, the strong one wins out, and therefore this solution will be basic. That is the resulting solution. In the second one, we have aluminum nitrate. And again, we're doing the do-si-do. They're changing partners, and we will get aluminum nitrate and nitric acid. Now, in these, you do not need to worry about balancing the number of atoms. However, it is critical that you get your formulas correct. And aluminum has a +3 charge, and nitrate is -1. And therefore, the common multiple is 3, so I need 3 nitrates in order to get my compound to 0. It is critical that you always double check those. Now, it's not aluminum nitrate, it's aluminum hydroxide. However, I still need 3 hydroxides because this was my salt with the nitrate. The nitrate then went with the hydrogen, and the aluminum went with the hydroxide. And this aluminum hydroxide is a weak base. And nitric acid is one of my 7 strong acids. When one is weak and one is strong, the strong wins. In this case, it becomes acidic. That's 2 of the salts that I will be doing in the warm-up, and I will come back to do the next 2. Now we have 2 more salts to work out. Again, we are doing the do-si-do. And bicarbonate is a polyatomic ion that stays together. In all of these reactions, the polyatomic ion stays together. And I get lithium hydroxide and carbonic acid. Carbonic acid is a little bit unusual, although it's in all of our soda drinks, our soda pops. We have carbonic acid in there. And so it's very, very common. Now, lithium hydroxide is a strong base. And carbonic acid is a weak acid. Therefore, remember, when one is strong and one is weak, the strong takes over. And therefore, this solution will be basic. In this final one we have in number 1, again we're doing the do-si-do. And we get calcium hydroxide and chloric acid. Again, I must write the formulas correctly, and calcium is +2 and hydroxide is -1. The common multiple is 2, so I need 2 hydroxides. Now, calcium hydroxide is a strong base, and chloric acid is a strong acid. When both are strong or both are weak, my resulting solution will be neutral. And that's the answer to number 1. In number 2, we are identifying if the compound is weak, strong, or a non-electrolyte. In the case of A, I know that it's an acid. It begins with hydrogen. It is not one of my 7 strong acids, so it is a weak electrolyte. Sulfuric acid is one of my strong acids, and therefore it is a strong electrolyte. N2O5 is an acid anhydride, and anhydrides are non-electrolytes. I believe from now on, instead of writing the whole word electrolyte out, I will just write an E, and then you'll know it's an electrolyte. N2 is a molecule, nitrogen, one of the diatomic molecules. It's not an acid, it's not a base, it's not a salt, therefore it is a non-electrolyte. Iron 2 hydroxide is a base. It's a metal with hydroxide. However, it is not one of our strong bases, which are group 1A and 2A with hydroxide, except for beryllium, and iron is not in that group. Therefore, it is a weak electrolyte. This compound is glucose or fructose or galactose. They all have the same formula, but different three-dimensional structures, so we call them isomers. That's just a little extra tip for you. And it is not an acid, a base, or a salt. It is a non-electrolyte. Na2O is a base anhydride. It is a non-electrolyte. H3PO3 is an acid. It's not one of our 7 strong acids, so it is a weak electrolyte. HBr is one of our 7 strong acids. Therefore, it is a strong electrolyte. All right, now we finished those 2 warm-up questions, and I'm so excited because we'll see you in the lab. I just love doing lab. It's just so exciting. Well, today I'm using pH paper to determine when I add these salts to water, what is the pH? Is it going to be acidic, basic, or neutral? That's what I'm looking for. I spread out a nice paper towel so that I have a place to add the water and the salts. The first salt, I'm going to go in order that they're given in the lab. And the first one is aluminum chloride. So I will add a little bit of aluminum chloride. That's a little bit more than a little bit, but it's okay. And we'll do a drop of water and see how this changes. And I need to give it a minute or a few seconds, and I can see that there is a color change going on here as it's reacting with the paper, and it's getting to be a red. Now, this is not only a qualitative lab where I am determining based on what I see, and I see a red, so I'm going to say that the pH is 1. The pH is 1, and my scale is here as well. That would be a 1. The next salt is ammonium chloride. I will add a few crystals to my pH paper and add the drop of water and give it 20 seconds or so to react and see if there's a color change. And I compare it to my chart, and I would say that that was a 4. That's what I would go with. There's no right and wrong answer here. I just read the number that I see. The next one that I'm doing is aluminum sulfate. I take a few crystals, put them on my pH paper, add a drop of water, let it react. It's getting a little bit green. I think I'll add a few more crystals. I see that it's getting somewhat green. And I compare it to my paper, I would say that that was a 6. Aluminum sulfate will be 6. The next one is copper 2 sulfate. I add a few crystals. Then I add a drop of water. Give it a little bit of time to add in there and actually react with the paper. I want to add another drop of water here. And I would say that this orangey color is the one that I'm going to go with, and it would be a 4. I'm going to go with a 4 for the copper sulfate. Iron, Roman numeral 2 sulfate. Iron 2 sulfate, I'll add to my pH paper, add a drop of water, give it a chance to sink in. Compare it to my pH paper, and I would say that was about, it's difficult to, but it's a judgment call. And I will call it a 3. 3 works for me. The next one is sodium acetate. I add my salt to the sodium acetate, add my drop of water, and I see that this color is a bit darker. I would say it's about 8 or 9. I'll go with 8. 8 for my sodium acetate. The next one is sodium bicarbonate or sodium hydrogen carbonate. I will add a little bit of that. It is actually baking soda. So let's see, is baking soda acidic or basic? Oh my, that's a dark blue. It's about, I would say 10. The pH is 10 for the sodium bicarbonate. And anything above 7 is going to be basic. And below 7 is acidic. So indeed, sodium bicarbonate is basic. The next one is sodium carbonate. Sodium carbonate, I add a few crystals. Then I add my drop of water. Oh my, look at that dark blue color. I'd say that was 12. The pH is 12 on the sodium carbonate. Wow, it's just like fun colors. The next one we're doing is sodium chloride, table salt. I'll add a few crystals. Then I add my drop of water. It doesn't seem to be doing very much. I think maybe I'll come back to that one. The last salt that we've been given is sodium phosphate. I'll add my crystals. Then I'll add my drop of water. And that is also a deep blue color. I don't really want the crystals on the pH paper, so I can read the color. I'd say that was 9. So sodium phosphate, accidents in lab happen. That's why we have to be prepared with our safety goggles and things. So I would say 9, and sodium phosphate would be a 9. pH is 9. Now I can go back and review the colors that I have here and see that there has been no major change. I did want to see that sodium chloride. There's not a whole lot of change there. It looks like 4. That's what it seems to be, is 4. And those are the colors that I get. There's a little bit of green on this as well. Do you see that little bit of green? I'm going to add a drop of water. I can see that it is probably, I'd say 6. Let's go with 6 for the sodium chloride. And that's how I determined the pH of these various salts. The next thing you have to do is prepare the write-up, and it has to have all the parts: the title, the objective, the data table, the conclusion questions, and the further investigations. We learned a lot today. That was some fun. Thanks for being with me, and I can't wait to see you tomorrow.